I have chosen to do number 43 from section 6.2. It says, according to flightstats.com, American Airlines flights from Dallas to Chicago are on time 80% of the time. Suppose 100 flights are randomly selected. A. Compute the mean and standard deviation of the random sample variable x, the number of on-time flights in 100 trials of the probability experiment. So first what we do is we have to determine what are we looking for. So they give us our p, which is 0.80. They give us our n, which is the number of times the flights that we're looking for. So it's 100. So first what we do is we look at the equation. The equation is the mean of x is then always equal to n times p. So what we first do is we plug it in. So it would be 100 times 0.80. And after that, we get a mean of 80. So once that will be our mean. So now we look for our standard deviation. Our standard deviation is basically n times p times 1 minus p square root. That's how you find your standard deviation. Next thing, you just plug in the numbers. So it's 100 times 0.80. So it's be 1 minus 0.80, which gives you 80 times 0.20, and which you multiply that gives you 16. So the square root of that will give you 4. So it's within 4 standard deviations. So now we go back to the problem and look at part B. It says interpret the mean. So we got 80 for a mean. So what can we interpret from this? We can say that we can expect 80 flights to be on time. Okay? And now we look back at part C. Would it be unusual to observe 75 on-time flights in a random sample of 100 flights from Dallas to Chicago? Why? I put it wouldn't be unusual for 75 flights to be on time because it's within 2 standard deviations of the mean. So because 75 is within we would say